One of the biggest benefits of carrying around a manual portable typewriter is the ability to take it basically anywhere, set it down, and start typing. Now, one of the things typists absolutely love about their portable typewriters is ease of use. And some of the easiest machines to use are electronic typewriters, but those come with a built-in problem, and that problem is the power cable. You can't take it into the beautiful great outdoors without having to plug it in. So to solve that problem, we have created this lovely machine, the world's first portable IBM Selectric. This machine can be taken anywhere you want, and it can type anything that you want. Setting up this incredibly portable typewriter could not be easier. You just set it down, you don't worry about plugging it in. Take a sheet of paper, you'll feed it in, just like that, turn it on, and you're ready to type away. So it's at this exact moment in the shop here that I decided to turn this into a YouTube video. Now, of course, I'll film the rest on my camera with a mic, or I guess whatever, we'll see. I got this 12-volt DC motor, and as you can see, the velocity clutch and the little motor belt gear thingy, whatever, I'm forgetting the name of it, it all fits perfectly on the factory shaft. Now, I thought that I would have to do some modification to this motor, but I'm pretty sure for experimentation's sake, I can just custom fabricate a mount and jam this right into the back side of an IBM. And I believe I even have a Selectric 2 on the shelf that would be a good candidate for this. Not these two machines, these are customer machines, but this one down here, oops, I fell off the shaft. Get back here, oh no. I'll just stick those up there for now. This one, right here, that's going to become a battery-powered IBM fucking Selectric. Ah, this is exciting. Yeah, okay. I'm really busy today. I got to get this Hammond out this week, and the wood base is still in shambles. So, look at that, so shiny. Okay, so yeah, this is going to have to wait a little bit, but I am so happy that this actually fits. I had some extra parts from motors, but I also have some parts from the motor that I take out of the shaft of the IBM. So this also comes with this fabricated mount, or whatever, this prefab mount. And I don't think that necessarily has the right hole line up. Holy crap, that might be a decent width to fit some of the screw mounts in this electric, but I will not shy away from trying to drill out the cast iron frames in these things, which I don't think is too bad, and I can do some experimentation to see just how well one of those might fit. This is a parch machine. It's heavy to frickin' do this one-handed, jeez. Get off the shelf, come on. Hang on, let me put my phone down. This is so portable. I could take it anywhere. I could hike for days. I could climb a small to medium-sized mountain with this machine. And then when I get to the top, I can draft a letter to my congressman. I could even do typing while I walk. See? It's so easy. The reason I don't like to film on my phone is because it's a pain in the butt to transfer files, but whatever. So this would likely fit somewhere around this. Now, the holes are spaced right, but they're not in line with each other. So depending on how I want this to fit in there, probably gonna have to drill new holes in the bottom of maybe this piece. Because I'm not sure. Oh shit, I just gotta take these off because I'm gonna lose them. Yeah, I'm not sure if I can reverse these screw mounts. But yeah, I'm basically gonna want this to sit right in there. And hopefully have a battery fit right there, or maybe in the top section there. And then we can see where this guy fits in. Potentially, so if we have it screwed in these holes here, the motor is not gonna reach the edge where it needs to be. So yeah, I might have to cut this in half. I guess I could flip it around, but even then, that's too much over. So yeah, we'll do some thinking about this. I would like to use this if possible because it's pre-drilled and everything. Likely we'll have to cut that in half right there and drill some extra holes. Hopefully that won't be too hard. The other thing I can do, actually, easier thing I can do, just thinking of that now, I'll just stick that wherever the hell I want it, grind off the paint, and weld it into place. Yeah, that'll be fine. I mean, welding sheet steel to cast iron is, you know, probably not metallurgically proper, but neither is sticking a battery in an IBM, so we'll do it and we'll see what happens. Okay, quick video update. I've got the motor on a motor mount here just to test fit everything and make sure that the belt in the machine is able to reach. And I just ground out that one section back there so we can fit it into that bracket there. And that's going to give us enough room to be able to adjust things around and get the motor exactly where I need it to be. And from that point on, we'll be able to just measure it out, adjust it, and then we'll weld it right along the bottom there. And hopefully we'll be able to get it nice and flat and everything. Okay, more horrible phone footage. Motor is installed, kind of, with a clamp. The belt seems to be pretty straight. We've got the hand cycle tool in there. So as we cycle it, the belt seems to be staying on our center hub very well. We're staying there pretty well. So basically we'll have that clamped and welded, but I'm actually going to attach a few electrical leads here. And let's do this off camera real quick. And we'll see if we can't power this on really quick. And try. And just see if this motor is even strong enough to power the IBM. And hopefully it's not going to like tear itself apart. So we'll turn this on. And there we go. It's spinning. It's a little bit intense. So maybe instead of 12 volts, we'll take that down to 10-ish. Sounds a little bit better. Yeah, it's a little bit faster than the normal IBM motor, but does seem to be driving pretty well. It's a little bit loud. Definitely will put the motor bushing back on so we don't have that weird clicky noise. But that's fine. Let's even drop this down a little more. So about 8 volts. It's idling a little bit slower. Sounds a little bit quieter. Okay, that is definitely slow. Let's bump that up to 9. Now this motor is rated 10 to 12 volts. Yeah, that actually seems about right. So 9 volts, I doubt that means we can run this off a 9-volt battery, but you know what? We should find out. Okay, I don't know if any of these batteries are good. So we'll grab, nope, not that one. Let's grab this one for a 9-volt battery. Plus. Apparently this battery's good. So let's connect it on here and see if we actually get anything. Not quite. It wants to go, not quite strong enough. Not quite strong enough. So, a little hack of doubling up the power of your battery, which is very sketchy. Okay, if I blow up Charlie, grab the fire extinguisher. Not doing anything, okay. Huh, maybe this battery's dead. Yeah, have you put batteries in series?
No.
Oh yeah, it multiplies the output of the battery. Okay, interesting. But a 9-volt battery doesn't have enough amps apparently to power it. Yeah, it should be good. I mean, this is completely DC power now. It's exciting.
That's cool.
Then I got to harass a friend to drive me out in the middle of nowhere and do video typing on it.
Where you planning on going?
I don't know, maybe the woods or something.
Yeah, if you want to plan on doing that after, I wouldn't be able to do it this Sunday, but like...
Oh yeah, probably be a couple weeks so I can get this done.
If you want to do that after work...
I can barely even feel the strain in my muscles. This is what everyday typing should be like. Oh my god. Okay, I think this will be the final video for today, and hopefully the final phone video. It turns out the cast iron or cast aluminum, whatever this is down here, actually, not magnetic, so thinking cast aluminum. Whatever it is, very easy to drill a hole through, so we have one screw right now going through it, bolting it down. That is enough, but I would like to get 2, so maybe back there we'll screw something down, or potentially use the existing screw hole and a washer to kind of pin it down on that back side there too. Because I'm not sure how accurately I'll be able to drill it down in from the bottom, but we'll see. But as of now, even though it sounds a little odd, it is working. It's stable, it's secure, and it is completely DC powered. So we'll go online today and just try and find a nice 9-volt power supply that's portable. Actually, let me go find my ruler. I'm closed up for the day. I'll come back here tomorrow for the full clean and everything. And, there's my ruler. This thing always walks away from me. But yeah, I'll come back for the full clean on the machine. It should be lubricated and serviced by the end of the week. And yeah, this project's been a long time coming. Glad we're getting it done now. Looks like we got about 3 inches wide by about 3 inches by about 2 inches. So conservative estimates 3 by 3 by 2, and we'll be just fine to fit something in there. We have maybe about 1 inch-ish by another inch above the motor. But yeah, something small, something compact. But I should also remember that this does have some room behind the case, in the back of the case as well. So we could fit, you know, up to 4.5 inches back there. But yeah. Obviously speed control, voltage control would be ideal, because we are not drawing consistent amps. You can see it goes a lot. Let's see, if we hit tab, it definitely dips and spikes. Same thing with return. So at idle, it's about 1.5 amps. And then when we hit return, it goes all the way up to almost 2.5. So yeah, it'd be nice if we had some sort of voltage control thingy going on, but it seems to be doing good enough for now. I don't think that battery-powered IBM Selectrics are anywhere close to being the future or the thing. This is just going to be a fun project, so yeah. Yeah, I'm very excited about this. Very excited about this. I thought about doing the Selectric 3 as well and wiring up the lights too, but we'll start simple with the 2. Oh, also before I forget, we'll be putting rubber bumpers in there because there's a lot of motor vibrations. So we'll put some rubber washers on either side of the motor, both of those side mounts there, and that'll help us with the vibrations. But yeah, very cool, very cool. I know I said no more phone video, but guess what? It's more phone video. So I just got a DC plug right here, and I'm wiring it now to the motor and the switch. So the switch is an IBM switch that I had in parts. Two of the wires are just straight pass-through, so I'll probably clip those out. And then the other two wires are the actual switch connectors. And then I have some heat shrink on both of these solder joints that are just going to slip right over there like that. And then we'll get the heat gun. I'll actually move my table over. We'll get closer to the heat gun and fry those into place. Okay, now the wires are a bit thin for the heat shrink to really fit all the way on them. So I think I'm going to just double secure it now with some tiny zip ties. That's going to help avoid strain on the wires, but it's also going to help keep that heat shrink in place so I don't have to worry about that slipping off. I don't do a lot of small electronics work, so I don't really have heat shrink that fits right. So that's why you see this terrible contraption going on here. Let's clip these so they're not in the way. I wanted to leave them live in case, or not live, available for attachments, but doesn't seem like that's going to be the case. Here's our battery. It has a maximum of 12 volts, but we're doing the 9 volt output. And it can deliver up to 6 amps, which is more than enough for the operation of the machine. Battery is a little bit chunkier than I'd like, but it does fit kind of in the back of the machine there. We might have to fiddle a little bit with getting it to fit exactly in the back of the machine. But for the most part, it should be okay. We can kind of mount that somewhere, maybe even extend the wires and stick it next to the keyboard on one of these sides. We'll deal with that another time, but for now, if we turn this on, the machine comes to life. And that is powered on the battery. Pretty good, pretty good. Turn that off. Need to do the lubrications on this, but I'm out of time today, so I'll come in and I'll do that tomorrow, and this should be underway pretty soon. Okay, I could not be happier with that. Obviously, I don't want wires pinched in the back, but I'll deal with that later. It's all together. That battery fits. We can turn it on, and the machine functions for the most part. Looks like our margins are down. There we go. Still need to do the lubrications on here, but it's actually functioning. Just to prove that this is working, I pulled it outside. There are no cables attached to it whatsoever. Completely free of any cords, any cables. And we can turn this on, and the machine powers up. This is very exciting. Okay, so there's one bolt down here.
What's up?
Oh, sorry, I'm just recording something real quick.
Okay.
Don't pay me any mind. And we have a second spot down there for another bolt. So it's a quick and dirty method of measuring out the 2 spots for bolts without actually having to remove anything. Oh, my tool doesn't fit. Come on. So at the center of that one, and if I can get that down there, the center of the next one. Perfect. It's hard to film with one hand and tool with the other.
Do you want me?
I got it. Just carefully remove my tool. Yeah. It's okay. I should have a camera and a tripod, but I don't. Okay. So then I should have put service feet on this. Let's see. We'll pull this to the edge of the workbench, and then we'll take the back end of our calipers, sticking one end into our screw head, we can kind of scratch an arc right into the aluminum, which will show us exactly where our next drill needs to go, or our next hole needs to be drilled, rather. To be right about there. And if we go and grab a level, we can make sure that that's square and in line with what the other one's supposed to be. So, on that magnificent journey to grab a level, we got one. We'll stick that roughly in line with the machine, which is dripping oil everywhere. They're nice and flat right there. Which is also kind of like a machinist block. And then, once again, using our calipers as a scribe, we'll give that bit of a vertical line. Well, it ends up being right on this flat section here, which I'm not a fan of. That's going to make it difficult to drill straight. Okay, and the screw hole has gone right through exactly where I want it. So we'll just stick a bolt down in there. Get it. Tighten it up. Should have a self-tighten washer. Okay, 2 bolts now. That is held tightly in place. So those rubber bumpers I mentioned, it's going to be a simple process of fabricating those with some 16th-inch rubber sheet and a small hole punch, so we can get 2 holes out of it. Pretty sure we could get away with just 2 of them. And then mallet and a center hole punch, we can chop out the 2 middles. And that is then 2 custom-sized small rubber washers that should help us with vibration control. I'm thinking we only need the 2, so we should be good with that, and I will go put those on the motor. Okay, I think the microphone's working. Yes, we are here with the IBM Selectric Typewriter. Spin that around and so that there's no cables attached anywhere. But we can turn this machine on. And we can type on it. So I'll bring the camera a little bit closer. It's our first proof of concept outside here. Let's see if we can't angle this for a better view. Focus up on it. Yes. Yeah, this machine is fully typing, fully functional, without being plugged into anything, because we have managed to get it completely battery powered. Probably gonna need a few more adjustments and things, but it is working. It is working. I've never experienced an easier to use, more portable typewriter than this wonderfully lightweight and portable electric typewriter. Okay, as I was mentioning before, this is the Oscar Wilde typing pose. Okay. Oh boy. Perfect amount of portability and convenience. All in one easy to carry package. Oh boy. Oh, that was really muddy right there. Careful. Oh.
Oh, you good?
I lost the mic. It doesn't like going up against the angle.